All right, so in this video, we are going to practice solving equations that involve fractions. So our I can statement is that I can solve equations by clearing fractions. So that's going to be our goal for this lesson. We want to be able to eliminate any fractions that stand in the way of us solving our equation. So the strategy is going to be the same for all of them. If you have an equation with fractions, to clear the fractions, we are going to multiply by the least common denominator of the fractions. So just to remind you what a least common denominator is it's when we find the smallest multiple two numbers have in common. So if I was doing 1/4 and 1/3, I would list out the multiples of 4, which are 4, 8, 12, 16. I'd list out the multiples of 3, which are 3, 6, 9, 12, 15. The smallest number both of these lists have in common is 12. So 12 would be my least common denominator. And so if I was solving an equation with these two fractions, I would multiply everything in the equation by the number 12. So let's take a look. Let's say that we had 2/3 x plus 1/6 equals 3. So if we think of the multiples of 3 and the multiples of 6, the smallest one they have in common is 6. So I'm going to start by multiplying 2/3 x by 6, 1/6 by 6, but I also need to multiply the 3 by 6. Every single term in the equation gets multiplied by 6. So just off to the side real quick, remember 6 is really over a denominator of 1. That's being multiplied by 2/3. When we do fraction multiplication, we can go straight across the top and straight across the bottom. That's the strategy to solve, which gives us 12 over 3. And 12 over 3, 12 divided by 3 is 4. That's one way to do it. Or a quicker way, in my opinion, is to cancel on the diagonals, because it's kind of like saying 6 is being divided by 3. And so 6 divided by 3 is 2. 3 divided by 3 is 1. And so we can simplify this diagonal to say that it's really 2 and 1 because we divided out a common multiple of 3. And so if I do 2 times 2, that's 4. 1 times 1 is 1. And we know 4 over 1 is 4. This kind of diagonal strategy makes the multiplication a lot easier. So I'm going to just do that here. Goes in once, 3 goes in twice. So 2 times 2x is 4x. And then 6 and 6 are both divisible by 6. So that gives us 1. And so it's really 1 times 1, which is 1. And then 6 times 3 is 18. Now 4x plus 1 equals 18 is a simple equation to solve. So we are going to subtract 1 from both sides. That gives us 4x equals 17. And then all I need to do is divide both sides by 4. And we leave our answers as improper fractions. You don't need to go any further. I don't want 4.25. I don't want 4 1/4. I want 17 over 4. So let's do one more example, a little bit more challenging this time. So I have 1/5 times 3x minus 1 plus 3/2 equals 2x minus 4. So the two denominators I'm looking at are the 5 and the 2. So the least common denominator is going to be 10. So I'm going to multiply here by 10. I'm not going to multiply inside the parentheses because 1/5 was getting distributed. If I were to multiply the 1/5 by 10 and then these numbers by 10, it would be a double multiplication. I'd be multiplying out here by 10 and in here, so it would be too much to do both. So you only need to multiply the coefficient. but I do need to multiply here by 10, here by 10, and here by 10. So 10 times a fifth is 2, because on my diagonal, 5 and 10 can be divided both by 5. 5 divided by 5 is 1. 10 divided by 10 is 2. And then I do 2 times the numerator 1 to give me 2. I don't touch inside the parentheses. Then here, 10 and 2, they both can be divisible by 2. 2 divided by 2 is 1. 10 divided by 2 is 5. 5 times the numerator 3 is 15. 20x minus 40. Great. Now we have an equation that's much simpler to solve. So I distribute my 2 to start. Then I need to combine my like terms. Negative 2 and 15 make 13. Then I need to get my variable to one side. I like to be left with positive coefficients, so I'm subtracting the 6x. That's gone. I'm left with 13 equals 14x minus 40. Add 40 to both sides. And then last but not least, divide by 14. And sometimes we get these pretty gnarly looking fractions from these types of problems, but we're just going to leave it in proper